Wave optics. Sir Isaac Newton stands as a prominent figure that supported the voice of particle nature of light, who proposed corpuscular theory, which states that light consists of extremely light and tiny particles known as corpuscles, which travel with a very high speed from a source of light to create sensation of vision by reflecting on the retina of the eye. So this is Sir Isaac Newton's corpuscular theory. Now, what is Huygen's wave theory? Christopher Huygen proposed his wave theory of light in early 18th century. According to Huygen's theory, light consists of waves which travel through a very dilute and highly elastic material medium present everywhere in space. This medium is called as ether. As the medium is supposed to be very dilute and highly elastic, its density would be very low and modulus of elasticity would be very high, so that speed of light would be very large. So in the image you can very well see that this is the Huygens principle. Each point on a wavefront acts as a fresh source of disturbance of light. The new wavefront at any time later is obtained by taking the forward envelope of all the secondary wavelets at that time. Laws of reflection basing on Huygens principle. If c be the speed of light, t be the time taken by light to go from B to C, here in the image you can see, or A to D or E to G through F, then mathematically T is equal to EF by C plus FG by C. T is equal to AF sin I by C plus FC sin I by C. So T is equal to AC sin I plus AF whole into sin I minus sin I by C. For rays of light from different parts on the incident wavefront, the values of AF are different, but light from different points of the incident wavefront should take the same time to reach the corresponding points on the reflected wavefront. So T should not depend upon AF. This is possibly only if sin I minus sin R is equal to 0. So we derive the equation sin I minus sin R is equal to 0. That's why sin I is equal to sin R or I equal to R. So our conclusion of laws of reflection on the basis of wave theory are: the angle of reflection R is equal to the angle of incidence I for all wavelengths and for any pair of materials. So I is equal to R. The incident ray, reflected ray and normal to the reflecting surface all lie on the same plane. Now, laws of refraction basing on Huygens principle. The refraction of light when light enters from a rarer medium to a denser medium. Let V and C be the velocity of the light in the denser medium and the air respectively. The laws of refraction are: the ratio of the sine of angle incidence to the sine of the angle refraction is constant for any two given media. Therefore, sin I by sin R is equal to C by V is equal to a constant, where mu is constant called the refractive index of the medium with respect to air. Then the second law is: the incident ray, the refracted ray and the normal at the point of an incidence on the refracting surface lie on the same plane. So these two are the laws of refraction. So here mathematically, if c be the speed of light, t be the time taken by light to go from B to C or A to D or E to G through F, then T is equal to EF by C plus FG by V. T is equal to AF sin I by C plus FC sin R by V. So T is equal to AC sin R by V plus AF whole into sin I by C minus sin R by V. For rays of light from different parts of the incident wavefront, the values of AF are different, but light from different points of the incident wavefront should take the same time to reach the corresponding points on the refracted wavefront. So T should not depend upon AF. This is possible only if sin I by C minus sin R by V is equal to 0. That's why we derive the equation sin I by sin R is equal to a constant. What is wavefront? A wavefront is defined as the laws of all points of the medium which vibrate in the same phase. Depending on the shape of the source of light, wavefronts can be of three types. So, wavefront is an imaginary surface representing corresponding points of a wave that vibrate in unison. When identical waves having a common origin travel through a homogeneous medium, the corresponding crests and troughs at any instant are in phase. That is, they have completed identical fractions of their cyclic motion, and any surface drawn through all the points of the same phase will constitute a wave front. So let us know about the spherical wave front. When light is emerging from a point source, the wave fronts are spherical in shape. So in spherical wave front, amplitude of light waves A is directly proportional to 1r, and intensity of light waves I is directly proportional to 1r square. Cylindrical wavefront. When the source of light is linear, the wavefronts are cylindrical in shape. All the points are equidistant from the source. So here in the image you can see this is the source and all the points are equidistant from the source. Then the third one is plane wavefront. When the light is coming from a very far up source, the wavefronts are planar. For a plane wavefront, amplitude remains constant, therefore intensity remains constant. So in the image you can see plane waves have wavefront that lie in planes that are parallel to one another. So guys, we just discussed about laws of reflection, laws of refraction basing on Huygen's principle and Sir Isaac Newton's corpuscular theory. And we also discussed about various wavefronts. So for detailed study of this chapter, you can visit to our website www.syft.in. Thank you.